Okay, example number 4. Again, we can clearly see that we've got a product. My v here is in root form. That's obviously going to cause a problem when we come to differentiate, but we'll deal with that over at the side when we get to it. So u is equal to 2x and v is equal to the root of x squared plus 1. U dash is nice and easy, that's just 2. I can't differentiate that in root form, so I'm going to have to change my v, and instead of the square root, I'm going to put it to the power of a half. I can now differentiate that using the chain rule, so I bring my half to the front, and I subtract 1 from the power, which takes me to minus a half, and I multiply by the derivative of what's inside the bracket, which is 2x. If I tidy this up, my 2's cancel and I'm left with x times this bracket, but I'm going to put that bracket on, I'm going to write it with a positive power, so I'll bring it to the bottom and I'm going to put it back into root form. Okay. Right, so I've got my u, my v, my u dashed and my v dashed. So I can go to my formula to get dy by dx. My quotient rule is u dash dot v minus v dash dot u, all divided by v squared. Okay, so u dashed is 2 times v, which is the root of x squared plus 1. Take away v dash, which is this complicated looking fraction, times u, which is 2x. Again, this is the stage where I then often forget to put it all over v squared. But if we just put that in here, divided by v squared, so it's the root of x squared plus 1 all squared. Okay. Now, let me tidy this up a wee bit. We're obviously going to take away 2x squared on the top here, but we want it over a single fraction, this part. So I'm going to think of that as being over 1. Okay, and again, if I do a smile and a kiss, I'm going to multiply this part by another root x squared plus 1. So I've got 2 root x squared plus 1. Move that down a wee bit. Times another root x squared plus 1. Take away my 2x squared. That was all over root x squared plus 1. And that's all being divided by this here. Now that is the root of x squared plus 1 all squared. If you're squaring a square root, then they cancel out. So you're actually only dividing by x squared plus 1. Okay. Take it up here to start to tidy it up a wee bit. Again, the root of x squared plus 1 times the root of x squared plus 1 just becomes x squared plus 1 itself. So I've got 2 times x squared plus 1. Take away 2x squared on the top here, divided by the root of x squared plus 1. And that's all being divided again by x squared plus 1. But if I'm dividing by that, that's the same as timesing by its reciprocal, which is this. Okay. So we're nearly there. We know that when we multiply that, the numerator is quite easy to take care of. If I look at the denominators though, they're both in terms of x squared plus 1, and I want to be able to gather them together. So although I like working in root form or surd form, I'm going to write that as a fractional power so that I can gather it with this power. So if we watch, the 2 times x squared is 2x squared plus 2 minus this 2x squared, and timesing all of that by 1 doesn't change it. But I'm going to have x squared plus 1 to the power of a half times x squared plus 1 to the power of 1. Now we normally don't write a power of 1, but you'll see why I'm going to do that. So my 2x squareds cancel on the top, so I'm left with 2. I've got a bracket to a power times the same bracket to a different power. So because they're both in the same base, if you like, for example, if I had x to the 2 being multiplied by x to the 3, that would become x to the 5, wouldn't it? Using my rules of indices. They're both in the same base of x, so you can add the powers. Well, these two are both in the same base of x squared plus 1, so you can add the powers here. Okay, so a half plus 1 is 1.5, which we know we can write as 3 over 2. Okay, and if we just tidy up that last part, I'm going to put it back into root form. We could write that as the square root of this squared. So 2 over the square root of x squared plus 1 cubed. And there is my dy by dx. Okay, so again, the skill set itself is not particularly difficult. The process of the quotient rule is quite easy, but it's the manipulation of the algebra which is going to catch some of you out. And what you'll remember from higher is probably this final part where you're tidying it all up is usually only worth about 1 mark. Okay, so if you mess it up, don't worry about it too much, but it's practicing your manipulation of algebra which you want to work on here.